All right, so you've heard the buzzword, right? Quantum computing. It sounds huge, complicated, maybe even a little sci-fi. But what is it actually? Well, that's exactly what we're going to break down today. We're going to pull back that curtain and make sense of it all.
So let's start with a crazy what if. What if you had a computer that could explore every single possibility, all at the exact same time? Seriously, think about that. It's not just about speed. It's a completely different way of thinking, of solving. And that is the heart of what quantum computing promises.
Okay, so how on earth does that even work? Well, to get it, we've got to go right down to the basics, to the single most fundamental difference between the computer you're using right now and a quantum computer. And it all comes down to a brand new kind of bit. And what's wild is that this huge difference starts with something super simple. See, your phone, your laptop, everything runs on classical bits. They're just switches, right? On or off, 1 or 0, that's it. But a quantum bit, or a qubit as they call it, is a total game changer. It can be a 0, it can be a 1, or, and here's the mind-bending part, it can be both at the same time. The best analogy? A regular bit is a light switch. It's on or it's off. A qubit is like a spinning coin. It's kind of heads and tails at the same time, right up until the moment it lands. So this whole idea of being in multiple states at once, it means qubits are playing a totally different game. They don't follow the rules we're used to. Nope, they operate in the weird and wonderful world of quantum mechanics. And that world is built on two, well, let's call them magic principles: superposition and entanglement. First up is superposition. And really, that's just a fancy science name for that spinning coin thing we were just talking about. It's the property that lets a qubit hold onto a 0 and a 1 simultaneously. This is the how. This is the secret sauce behind its power. But here is where things get really interesting. This isn't just a small step up. The power of these qubits, it doesn't just add up, it multiplies. It grows exponentially. And honestly, this is the reason classical computers just can't keep up. Every single time you add just one more qubit, you literally double the computer's power. Let's look at what that actually means. You have 2 qubits, boom, that's 4 states you can work with at once. Okay, now let's add just one more, bringing us to 3 qubits. Now you're at 8 states. Add another, 16. You can see how this just explodes, right? The numbers get crazy fast. So get this, just to really hammer the point home, if you have just 10 qubits, only 10, that tiny system can handle 1,024 states simultaneously. A regular computer, it would need 1,024 separate bits to even come close. The efficiency isn't just better, it's on another planet. Okay, so that was superposition. Now for the second quantum rule, and if you thought the last one was weird, buckle up. This is called entanglement. So imagine you have 2 of our spinning coins, but they're connected somehow. They're linked in a deep, mysterious way. If you stop one coin and it lands on heads, you instantly know, instantly, that the other coin is tails. It doesn't matter if it's across the room or across the galaxy. It's this bizarre, spooky connection that lets these computers handle ridiculously complex problems. All right, quick recap. We've got qubits that can be both 0 and 1 at the same time. That's superposition. And we've got qubits that are mysteriously linked. That's entanglement. But so what? Right? What's the point of all this weirdness? How do we actually use it to solve the kinds of problems that make even our biggest supercomputers just give up?
Well, here's the basic recipe for a quantum calculation. First, you get your qubits ready. Then, you use these things called quantum gates to push them into that powerful superposition and entanglement state. Now, the magic happens. The computer explores this massive landscape of potential answers all at once. Then, and this is my favorite part, it uses something called interference. Think of it like noise-canceling headphones for math. The wrong answers get canceled out, and the right answer gets louder and louder. And finally, you take a measurement, which basically means you look at it, and poof, all those possibilities collapse into one single correct answer.
Yeah, there's a great way to think about it. It says that quantum algorithms are all about guiding probability waves. You're not just smashing through a problem with brute force. It's more elegant. You're like a conductor, gently guiding all these possibilities so that the correct solution becomes the most likely one to pop out at the very end. Let's make this real. Imagine you're searching a giant, messy database for one specific thing. A normal computer, it has to go through it one by one by one. It's slow. But a quantum computer, using what's called Grover's algorithm, whoa, it gets a huge shortcut. So in a database with 1 million items,
A classical computer might have to make 1,000,000 guesses. Grover's algorithm? It can find it in about 1,000. That's the difference we're talking about.
And that leads us to the big one, the one that gets everyone's attention. A huge part of our online security, banking, private messages, all of it, relies on one simple fact. It's basically impossible for normal computers to factor really, really big numbers. How hard is it? Well, to crack a standard 2048-bit encryption key, our best supercomputer would need billions of years. A powerful quantum computer using something called Shor's algorithm, it might do it in a few hours. Yeah, you can see why people are already racing to build quantum-proof security.
But look, it's not all about cracking codes and searching databases. That's just the tip of the iceberg. This new level of computing power is set to completely shake up, well, pretty much everything. We're talking about changes that could affect our world in some really fundamental ways.
I mean, the possibilities are just staggering. Imagine creating new medicines and vaccines in record time because we can finally simulate molecules perfectly. Imagine building financial models that are so complex they're literally beyond our current imagination. We could supercharge artificial intelligence, find the most efficient shipping routes on the planet and save billions in the process. The list just goes on and on.
Okay, so after hearing all that, it's easy to get carried away. So let's take a deep breath and come back down to earth for a second. This technology is absolutely revolutionary, but it's also still very, very new. There are some huge hurdles we have to get over before any of this becomes a common thing.
For starters, qubits are, well, they're divas. They are so incredibly fragile. The tiniest little vibration, a slight change in temperature, and boom, it can lose its special quantum state. That's called decoherence, and it just completely wrecks the calculation. This sensitivity means they make a lot of errors. Not only that, but a lot of these computers have to be kept at temperatures colder than deep space. So just physically building bigger, more stable machines is an unbelievably hard problem to solve.
So let's be super clear about something. A quantum computer is not going to replace your laptop. You're not going to be browsing the web or checking your email on one of these things. The best way to think about them is as highly specialized tools for very specific jobs. Our regular computers will still be for all our everyday stuff, and we'll just hand off the impossible problems to the quantum computers that are designed to chew on them.
Look, if there's only one thing you remember from all of this, let it be this simple idea. It really sums it all up. A classical computer is like someone trying to find the right key for a lock. They have to try every single key, one by one. A quantum computer, thanks to superposition, it's like it can try every key in every lock all at the same time. And it finds the one that works almost instantly.
So no, your computer isn't going anywhere, but the world around it is about to change in a big way. The medicines we develop, the way our financial world works, the scientific breakthroughs that define our future, all of it is going to be touched by this. Quantum computing isn't just a possibility anymore, it's happening. And it's going to give us the keys to solve problems we used to think were completely unsolvable. And you know what the most exciting part is? It's thinking about all the incredible things it will do that we haven't even imagined.